For folks online, we're going to start in about 2 minutes. Yeah, come on down. Sit right up here. Sure. Does it sound good?
Yep. I was just making sure you had it recorded.
Yeah, I did start it. Great. Yeah. We'll start in about a minute or two. Okay, well, I think we're going to go ahead and get started. We have other people that are going to keep coming in as they're stealing cookies outside, and we welcome folks online. It looks like we're up to about 29 people online. I think we had a little bit over 120 people, register, so it should be really good. My name's Paul Westerhoff. I'm here at Arizona State University, and I'll kind of kick us off today on our panel. So the format of today's panel, I'm going to give a brief kind of introduction, a welcome, and then I'm going to hand it over to our moderator and 4 panelists. And you can see they're going to do some brief self-introductions. And somehow, Ron, if online, how do we get it such that we don't? Thank you. So the panelists will do brief introductions, and then we're going to have some facilitated questions for about 20 minutes, then leave it open, and we promised Enrique Vivone that we are going to be absolutely done by 6 minutes after, so he can get first pitch for the Diamondbacks and Phillies game. Yeah, if we could, we will. But we're going to hopefully have plenty of time for Q&A from the audience, so start taking notes. But it'll be kind of a facilitated discussion and then open discussion. So once again, my name's Paul Westerhoff, and the speakers will introduce themselves in a little bit. I'm in the School of Sustainable Engineering and the Built Environment, and the director of what's called the Global Center for Water Technology, and I'll talk a little bit more about that in a moment. So the Arizona Water Innovation Initiative is sponsoring this event, and you can see the quote from Michael Crow. This was an investment from our former governors, continued to be supported by our current governor, so water is one of those things that cross politics for sure. And so this Arizona Water Innovation Initiative, as you see it here, is really looking at strengthening the resilience of water in Arizona such that we can continue to be economically competitive, thrive, and all the other great adjectives. And the center, or the initiative, has 4 pillars. One of them that's hosting this today is a Global Center of Water Technology. Enrique leads the Water Observatory that looks at hydrology and modeling and understanding where the water is coming from. Impact Water Arizona looks at the governance and policy side. And Arizona Water for All is led by one of our recent MacArthur awardees, Amber Wutich. And that's looking at kind of the social equity part of water for everyone in Arizona and be sure that everybody benefits. And so with that, I'd like to start thinking about a little bit of background. In the 1970s, there was a lot of planning, starting of construction, and by the mid-1980s, a canal and infrastructure project moved water from the Colorado River into central Phoenix and all the way down to Tucson, where 2 of our speakers are from today. And if you look at today's portfolio of water resources, we get about 36% from the Colorado River, about 18% from other surface waters in the state, 5% from reclaimed, and 41% from groundwater. So it's really, you can see about 1/3 of our water now comes from this large infrastructure project that was planned decades ago. And it really helped fuel and maintain the economic prosperity of the state. But as we know, that prosperity is always threatened by Mother Nature and the long-term drought on the Colorado River. And so where we stand in that really has a lot to do with thinking about, where's the water future for Arizona? So should we do it again? Long-term into the future, you have to start thinking about these different scenarios. There's lots of scenarios. If you Google this, you can find anything. I just put some of the arrows. Some people think about coming from the north from the Columbia River, the Great Lakes, the lower Mississippi River, Pacific Ocean along California, Pacific Ocean in the Sea of Cortez. Thinking about much longer distances than moving water from the Colorado River, which flows through our state already. So today, we're here to talk about just one of these concepts, and it's kind of illustrative, but sometimes you have to go a little bit deep in order to kind of understand what some of the issues are. So we're going to talk about importing water from the Sea of Cortez into central Arizona. So the Sea of Cortez, if we look at it on a Google Earth rotated map, right, also goes by the name Gulf of California. I put it up because somebody who's online asked me, is that the same thing? And the answer is yes, these are the same things. And the blue line represents one of many possible trajectories, a way to get water from the Sea of Cortez to central Arizona. Now, water in the ocean is salty, about 32,000 milligrams per liter, so a lot higher salt than the Colorado River, really not very useful for us in Arizona alone. So you need to desalinate it, and this is a very simple scheme, but you take seawater, you have to bring it in. Sometimes this is from under the water, sometimes it's an intake structure, and you bring it and you have to do some pretreatment, remove algae, other particles and materials that would foul reverse osmosis, which are the desalination membranes. So these membranes are made out of polymers, kind of like a Jell-O, and water moves through the Jell-O faster than the salt moves through the Jell-O, right? And so clean water goes through and leaves the salt behind. There's not little holes or anything. It's really diffusion through a polymer. And of course, as you make the clean water, all the salt stays behind. So you have to put that salt back into the seawater. And there are concerns about how much water has that salt in it. How do you get it back in? How do you prevent ecosystems near that discharge? And then the reverse osmosis treated water is really clean. There's almost no ions in it. If you put that into a concrete pipe or steel pipe, it would corrode it away. So you need to stabilize the water so it's not very aggressive, and then put it in a pipeline. In this case, the pipeline from the Sea of Cortez to central Phoenix is about 150, 200 miles in length, and about 1,200 vertical feet in elevation. And we all know that water's heavy, right? And so really this elevation is a big issue because there's different amounts of energy in all of this treatment, a little bit in the intake and pretreatment, more in reverse osmosis, and a lot of energy is needed to pump the water uphill into central Arizona. And we'll be talking about these issues here today. So today, what we want to do is to talk about the technical, economic, and environmental questions around moving water from the Sea of Cortez to central Arizona, and really around the question, could we do it? We hope that this is just one in a series of seminars and panel discussions where other ones could address, should we do it? Why are we doing it? How could we do it? What are the alternatives to not doing it? So as you're going along today, we'd love feedback at the end, or send it to us on what future panels should do. But we really want to do kind of a deep dive into this one, the technical issues around could we import water from the Sea of Cortez. And so with that, what I'd like to do is to turn it over to our moderator and panelists, if they can come on up. Thank you very much.
Come on up,
give them a little bit of welcome as they come on up. And so, as you see here, a little bit brief bios on the panelists, but I'm going to hand it over to Duke. Duke is here at Arizona State University. He's an executive director, and for the University City Exchange, founder and executive director of something called Tenacross. Who's heard of Tenacross? There you go. Yes. So you can still put in a plug for Tenacross. And with that, I'll hand it over to Duke to moderate, introduce the panelists, and moderate the sessions.
Thank you.
We will do that. And if you are interested in 10 Across, go to 10, the number, 10across.com or .org, either one, and you will find out what we're all about. And it's how I've come to really understand a lot about water in the process. So before I introduce the panel, so really allow them to introduce themselves since you see their bios up there, short bios, I want to let you know what we're doing here today and also what we're not doing. I think you heard from Paul, he wants you to come away with an understanding of what desalination entails. So you understand it, if you will, technically. That was his objective for this conversation. Now, if you're gathering water from some other place, especially with another country involved, there are immense complications involved in that. We're really not going to go into that today. If we did, we'd never get to the things that Paul really wants us to discuss. But we're very much aware that that challenge exists. And we're going to come back to that probably in future discussions and have representatives from Mexico and elsewhere be part of that conversation. We have a lot to cover today alone. The other thing I want to reinforce that Paul said, we're not endorsing this solution. It's one of many that we're going to examine in subsequent conversations. But this is an interesting one to look at. It's got all the things you need to understand about the complexities of water in Arizona. So the way we're going to walk through today's discussion, we're going to talk about feasibility and timeline. We're going to talk about the environmental, socioeconomic issues. We're going to talk about then the technology and processes, the water itself, its quality. And finally, we are going to touch on the economics of doing something like this, which no doubt will get us a little bit into that binational discussion. So with that as a framework, again, I guess they took down the bios. I hope you can remember what was up there. I'm going to introduce my panelists, but then ask them to give maybe 2 to 3 minutes as to why they think they're here today, what they have to offer to this discussion, and how long they've been thinking about either this issue or water itself, because we have a really distinguished panel. First, on my left, Glenn Williamson is the founder and CEO of the Canada-Arizona Business Council and the chairman of the advisory board of EPCOR USA, a water company. Secondly, Chelsea McGuire. She's assistant director for external affairs, the Water Infrastructure Finance Authority of Arizona, or WIFA. Third, Kerri Hickenbottom, assistant professor of chemical and environmental engineering at the U of A. And lastly, John Take, the Chief Growth and Innovation Officer of Stantec. John had a different title when I first met him a few years ago. Many of the folks are good friends, supporters of 10 Across and other things. A few I've just met today. So we're going to kick it off with you, Glenn.
Thank you very, very much. First and foremost, thank you to ASU for hosting this. My background, I go back in water almost 40 years ago when I was on the Board of American Rivers in Washington, D.C., and after rafting the Colorado for about the 5th or 6th time, realized that that was kind of an important thing to get involved in, and have had a career around water doing different deals all over the world. Most recently, the company that I'm involved in as chairman, we've invested billions and billions and billions of dollars in Arizona and the water infrastructure here. So we have a really vested interest, as do other Canadian companies that are part of our 500 Canadian companies here in Arizona. So the 3 largest private water utilities in the state of Arizona are all Canadian. So that means Canadian capital has been pouring down here, no pun intended, with an interest in the community. And it is something that we want to make sure that we are giving back in every way we can by starting a conversation in depth on long-term water augmentation opportunities and options. And as Duke said, we are not interested in any one option right now. We are interested in looking at everything. And there are professionals on this panel that will take that even further. But my job as a financier and a water person and a chairman of a water company is to make sure that we're doing the right thing, not only for the state of Arizona that needs water, but wherever that water comes from, that we do the right thing there, and everybody is in on this, and we're not just looking at places and saying, we're going to take your water and there's nothing you're going to get. We have to make sure that reciprocity and equality of whatever we do with water in the region is equal to all parties, giving and taking.
Chelsea.
Well, thanks, Duke, and I'll echo my thank you to ASU for having us today. I am here on behalf of the Water Infrastructure Finance Authority, or WIFA, as we are affectionately known. And I'm glad you asked the question the way you did. Why do you think you're here today? Because 18 months ago, WIFA would have had no business being on a panel such as this. But in 2022, the Arizona legislature made a historic investment in water security and Arizona's water future. And that investment came through WIFA. Traditionally, we were a finance authority that used federal money to do clean and drinking water projects through low-cost financing in communities. But the legislature said, we want to go even further, and we want to invest state funds in bringing new water into the state. There are other aspects to that investment as well. It includes some rural infrastructure investments. It includes significant conservation investment. But the real bulk of that, the real bulk of a committed $1 billion was water augmentation, and specifically water importation, bringing water into the state from outside the borders of Arizona, wherever those arrows might have landed on that slide. And it is kind of fun for me to be on this panel, honestly, because my agency right now, the authority, is asking a lot of the questions that are going to be asked of the people who are sitting here. And that's happening for a few reasons. Some of you may have been following the news back in December when our agency was proposed or was presented with an unsolicited proposal for exactly what the title of this program is, a desalination program in the Sea of Cortez. And our board looked at that and they said that's very interesting, and that's something that we absolutely think could be a part of this investment that we're making. But we have so many questions and we have so many things that we need to know before we can decide what's the best way for us to invest this money that we've been given, this money that this state has committed to bringing new water into the state. So I think I'm going to be taking as many notes as maybe you all in the audience are taking on some of the answers to this. But what we can really contribute to the conversation is, what is our process for answering those questions? How are we going to take the technical expertise that we have from out in the industry? How are we going to take the additional available financing and interest in these kinds of projects and put it together to make a portfolio that works for Arizona and that brings in the water that our communities are telling us that they need, that our economy needs to do what it's trying to do and that what it wants to do? That's really going to be our job. So I get to talk about that process today, how it's going to be competitive, how it's going to be transparent. It's probably going to take longer than I would like it to take as a pretty impatient person, but it's there. And I think that's the important part for us to remember, that that's why WIFA is here in the conversation today. It's because we can be the clearinghouse for the ideas, the catalyst for the investment, and the agency, the authority that really brings it all together for the benefit of the state.
Great. So Kerri, you've been investigating many of the technical issues affiliated with desal. Tell us a little bit more about yourself.
That's right. Well, thanks everyone for being here, and thank you for inviting me to be on this panel. So my expertise is mainly in membrane-based processes, so both conventional and novel membrane-based processes for inland desalination, water reuse, concentrate management, and then also looking at, how do we integrate these systems into our communities and into our existing infrastructure by also using renewable energy resources. I do a lot of techno-economic and life cycle assessment, and I work at a much larger scale than most researchers do. So I really try and bridge the gap between some of these novel processes that we're looking at for different types of water uses into the community scale. And so, yeah, my technical expertise resides there. I work a lot with municipalities, utilities, industries, and a lot of it, again, is looking at like the intersection of water and energy. So how do we produce water at a low cost to make it safe and sustainable, for everyone to access?
So John, can you give us an assessment of the pitching lineups tonight?
Yeah, no, hockey would be a different matter, however. So my name's John Tate, and I work for Stantec, a global consulting firm. And previously I led our water business globally. And so I've spent 30 years working with communities that either had too much water or not enough. And so I spent, for example, 7 years in New Orleans after Katrina working to help that community reduce its risk And my reason for being here today is I'm really interested in seeing a robust conversation in Arizona around our long-term water story. I think there's a lot of confidence in our near-term water supply. I think also that engineers love to design things that last for hundreds of years. And so we need to ask really good questions about what do we need when we think about our community on a very broad scale. What are the discussions we should be having now, especially when the world around us is changing so quickly?
Mm-hmm. Great. So you can see why we have these four people and the experience and the intellectual capacity and technical capacity they bring to this question. So the first question that we thought we would ask them was if regulations and permitting and other obstacles were just not an issue, how quickly could this project happen? So Glenn, I know that one of the things that makes you happy about this discussion is that you have a strong belief that if we're going to do something, we need to decide what that is, whatever it is, soon and get started. Because as our good friend John would say, who has to build some of these things, it's going to take a while. Tell me about the urgency you feel around time and the decision-making process.
So a couple of things are coming together in the global world right now. We're watching infrastructure become very important in the United States again. And the capital markets that fund this to the tunes of billions and billions of dollars are looking at the US again. And Arizona needs to put its hand up and say, we've got Project A for 10 billion and Project B for 20 billion. And I think in my world that the way that Arizona is growing exponentially right now, when I look at our economic developers, not only in Arizona, but in Sonora, Mexico, and I see that everybody is growing so quickly that we as a region need to take a look at some of our infrastructure while capital markets are very much in our favor. Do I believe there's a lot of complexities to building the solutions? I do, but I also believe that companies like Stantec have the ability to fix that. Do I believe there's lots of very complex decisions as to which one needs to happen? I'm sitting beside two people, ASU and WIFA, that their task is to figure that out. So in my world, as someone who is involved in water, I know that there is a moment in time, somewhere 25 years down the road or so, where we have to plan forward. Just like the dams had to, like CAP had to. We need to look at short and medium term with all the experience we have. And then we should be looking, there should be an emphasis looking down the road. And that's why a year and a half ago, I asked Stantec as one of our CABC members to show us all the options that were out there possible. And it was huge. And then the best thing that happened after that was WIFA was formed. And WIFA's task is to take a look at all of those things and put it forward. And then right after that, I couldn't have had a better phone call with Michael Crow, where Michael, I said, would you please use ASU to help us justify and understand which decisions are the right ones to work with, which is why professionals like Paul and professionals like you have been so extraordinarily helpful in helping us to understand before we prematurely make any decisions. But that being said, within a year or so, we should know what we want to do. And if it involves Sonora, the government of Sonora, we should ask them what their problems are and fix that. If it involves California, we should ask California what they want. If it involves any other state, we should ask what they want and not just assume, such as other people have done, that we can just go in and do that. Technically, we have all these abilities, but I think we have to really go through this process that these professionals around, not me, I'm along for the ride going, tell me which one we want to fund and point us in the right direction so we know where we want to go.
But you do bring that sense of urgency, and you want us to go through this process, which, Chelsea, you're really pushing as well through WIFA and your RFI. Do you feel the same sense of a timeline resembling what Glenn just suggested?
We do. We feel the same sense of urgency, certainly, and it's exciting that we can sort of give a tangible timeline right now, at least on the WIFA side. So as Duke mentioned, we do right now have a request for information, or an RFI, that has been published. And the purpose of that is to define our universe, because what can happen in a situation like this where you have a lot of resources, you have a lot of enthusiasm, you have a lot of need, there can be a lot of analysis paralysis too, because it's just such a wide span of things that you could do with the resources that are there. So we have a multi-step process in place, and the RFI is the first step in that process to define the universe of what is a good idea. What are their technical experts saying is a good idea in terms of how we actually get the water, where it comes from, where it's transported, how it ends up in Arizona. Also, what are the right financing mechanisms for that? Is it a public-private partnership? Is it simply low-cost financing? What does the market actually need to do to attract those kinds of projects? The deadline for that is November 15th. That's next month. It's coming up very quickly. So we will know by the end of November sort of where that lies and have a much better picture of what that looks like. That information will then inform an eventual procurement or a solicitation out into the market to say, all right, now you've given us your ideas, come to us with actual proposals. What can we actually finance? What will that look like? That is expected in the spring of next year, sometime in probably March or April, which means that we could theoretically actually have that project identified by the end of next year. That is an extremely feasible timeline. It's exactly what we're working towards at WIFA and what we're really trying to do. And I think it shows we're serious about the project and we have the resources to be serious.
So as Paul pointed out at the beginning of this, we're interested in the technical issues affiliated with the desal solution, for example. So in your estimation, John, since you build these things and you've looked at examples of them around the world, and my question at the beginning was, if all the obstacles were easily overcome, what's a logical timeline from start to finish? You've got water being produced by this system. What should we guesstimate that is?
So I think the best predictor of the future is often things that have happened in the past. So you look at what's happened with desal in the United States before, and there are timelines that run 14, 15 years. There's a project that California recently decided not to do that took 17 years to work through not doing a project. And so to answer your question, I think, and I'd never call engineering trivial, but I think there's a process. You have to go out and you have to really understand the water you're trying to treat. So you have to sample it for 6 months. And then you need to go and do planning and engineering and design and then construction. And so, nominally 4 or 5 years to work through a process like that, but easily 10 years to decide, is this a project that we should be doing? The best infrastructure is no infrastructure. It's very cheap, doesn't break, and deciding that no one wants a pipeline or a canal running around Arizona looking for a problem to solve, and deciding that this project really addresses shared challenges that we have with our neighbors, whether they're to the north or east or west or south. We have shared challenges of climate change, we have food, energy, and water challenges. Deciding that project formulation and identifying the optimal concepts and then working on them collectively in a collaborative approach to make sure we're solving. I think the upfront Imagineering is a critical part, and I think the actual design and construction can actually happen fairly rapidly, but no one wants to build something that we don't need.
And I want to reiterate what we said at the beginning. We also understand we're dealing with another country for this particular solution, which certainly adds complexity, and all of you have vocalized the idea that we should be thinking about solutions that benefit everyone. It's also a long distance. Often desal plants are closer to the place that are being served, so this one has that complexity. There's a lot of uphill pushing of water in this particular one. So this is a complex challenge, there's just no doubt about it. So one of the things that comes with desal is the byproduct. And clearly, that's why it's called desal, right? We're removing that salt, which produces this brine. So let's talk about the environmental issues affiliated with that. So, Kerri, I'm thinking this is your area of expertise, although I think a lot of people are familiar with it. Talk to us about what's the obvious issue with desal, which would be this issue.
Yeah, so one of the biggest issues is concentrate management. Because this desalination facility would be in Mexico in the Gulf region, we do have access to the sea where we could dispose of this concentrate. The thing is just like how we would need an intake structure, you would need essentially a discharge structure as well. And generally what they use for coastal desalination facilities are these high velocity diffusers. And so these can have ecological impacts to the surrounding areas. The reason why you want a high velocity is because you're trying to have good mixing in your system. Generally, for seawater desalination, we concentrate the water 50% of what is coming in. So for example, seawater is about 35 grams per liter. We would concentrate it to 70 grams per liter. So you would need these high velocity diffusers. And there's been studies, long-term studies in Australia that have looked at the ecological impacts, and it does have impacts on the local marine environment. Another big problem specifically with this area is that it has some of the largest tides in the world. They can range from like 4 feet to 40 feet, depending on the celestial patterns. So that's another big problem or consideration, because you're going to need a really long intake and an outtake structure to facilitate desalination in this region.
That's such a great point. I think people would assume, I'm at the water's edge, right? The pipe goes there, no problem. No, you've got to go way out to accommodate what you just described, which is easily forgotten. John, you mentioned not just pouring the brine back into the ocean, but maybe putting it underground.
As well, we've been looking at, in that concentrate, there's actually valuable materials. There's particular different elements that you can recover, not to mention, obviously, there's a lot of salt you can recover, which is not as valuable. But, we've been looking at additional technologies which would reduce or eliminate the actual discharge back to the ocean. And that would go through to a full crystallization process, not quite full zero liquid discharge, but as close as you can get. And we've also been looking, the project over in California is how can you pair carbon capture with that same process as you work through that. In Arizona, they build up some expertise. There's another RFI out in Arizona looking at brackish groundwater desal, and that may be an opportunity to explore some of the technologies that I've just talked about that would greatly reduce the environmental impact of the discharges.
So the second thing that's typically brought up with desal, in addition to the byproduct and what to do with it, is the energy that it takes to move this water around, which is, I think, has already been pointed out by Paul and others. It's pretty heavy. Now, we have a history of moving water a long way across a desert to get to a place where we can use it. And we had to build power plants to do that. So, Chelsea, as you're thinking about this, factor in what we need to be thinking about in this RFI with regard to energy, as you imagine it.
So we imagine that the successful proposals, and I'll reiterate too, a successful proposal might not be for desalination in the Sea of Cortez, right? But that's what we're talking about today. That's kind of the context we're looking at this in. But any successful proposal that our board ultimately approves and ultimately decides that's what we're going to invest in has to be that complete package. And we have to look at how are you going to deal with the brine? How are you going to deal with that ecological impact? How are you going to deal with the ecological and environmental impact of transporting the water and whatever that means? And how are you going to transport that water? And if there's not a complete package that shows how we get from point A to point X, Y, or Z, then that's probably not something that is a wise investment for the state. And we're going to have to take all of that into consideration before the investment's actually made.
And as you well know, in this particular example we're looking at today, among the many that we could, those pipes are going to have to go through a UNESCO site. This is a very valuable landscape that is revered by many, and so it has that complication. Glenn, I know you've talked to your friends in Mexico and elsewhere and surely thought about this a little bit. The complications therein, what do you think?
So should the powers that be point towards Mexico, one of the things that we've uncovered in many discussions with my friends and partners in Sonora is that we have made discussions to them about what do you need and what can we solve for you in Sonora, for Sonora first, before we go and do anything else. How can we, as financial, engineering, and other type of partnerships, help Sonora solve its water problem and then fix our water problem? And to put this in perspective, forgetting about what the Sonora cost will be, whatever we play with is in the $20 billion range. So let's put that in perspective. We have a billion or less in Arizona. which means the private sector, from a P3 point of view, is going to have to step to the plate. Which, by the way, the reason I just took 6 legislators up to Canada to meet with 5 funds that control roughly $4 trillion, they make direct investments. The private equity markets around the world invest in these kinds of things. It's not just governments. If you take a look at Sonora, Aqualia, which is a Spanish company that a Mexican happens to own, would be a fantastic partner to help solve a problem down in Sonora. And once we solve Sonora's problem, then they can help us solve our problem. And the discussion will be, how much do you want to pay for the water? Because you're moving water at that point.
Which we're going to definitely hit on the issue of how much you're willing to pay for that water as we close out this discussion. And some of the challenges that we've seen in the past, maybe not everybody started with the way you just described this, Glenn. What can we do locally first before we imagine what we need, which would seem to be essential. Okay, now the technology of this, and there's been discussions about how Arizona can be a leader in developing this, the role of the federal government to invest in this. John, the technology that we might use today, and maybe Kerri, this is for you as well. How confident are we in that technology? How is it going to evolve, and how does a plant or whatever we build accommodate changes that will surely happen in the next 5, 10, 20 years, such that this maintains its integrity and is still doing the job maybe even better than was imagined? Tell us about the technologies. Kerri, why don't you start?
Yeah, so the technology at this point, seawater desalination isn't a new thing, right? People have been doing it for a long time. In the Middle East, they really predominantly started seawater desalination there, in Australia, and then coastal California has also been looking into it. And at this point, the technology is reverse osmosis. Before, they used to do thermal desalination processes, but we've done such a great job. There's been a lot of investment in developing this technology that it's at the thermodynamic limit. So, in our community, we argue, we're at the upper bound, and this is the best we can do in terms of like the membrane technology. There are some interesting things and really good opportunities, especially in the zone that's being pursued for combining it with tidal energy. One of the things that we haven't looked at, and that's not really understood, is how intermittent operation of these reverse osmosis membranes perform. So there can be a lot of stress and strain and additional membrane fatigue. So even though that could be a really good source of energy, renewable energy that could be directly coupled, there would be a lot. We're really not there yet with understanding, how it has some downstream impacts in terms of, membrane fatigue and membrane replacement. If you want to add to that, John?
Before we go on, for the benefit of all the people in the room who want to throw the words reverse osmosis around tonight over dinner,
Yeah.
give us the 30, because we hear that, and people talk about desal like they know what they're talking about as well. Reverse osmosis is what?
So reverse osmosis is a membrane-based process. It's essentially what Paul was saying. You have a polymer. It's made from plastic, essentially, more or less, polymeric materials, and it's a really tightly woven. It's a material, and the way that it works is just through diffusion. And we have a hydraulic pressure that we apply to our feed water, so that in this case it would be seawater. And that hydraulic pressure has to be higher than the osmotic pressure of the feed water. The osmotic pressure is basically proportional to the salinity in the water. So we apply a pressure. It can be a pretty high pressure because the higher the salinity, the higher pressure. And then water permeates through the membrane. These membranes are so tight that they only let molecules at the angstrom level pass through. So we're really just talking about water. That means it has a really, really good rejection of salinity. So like monovalent ions like sodium chloride, which is most abundant. It's like 80% plus or something of seawater, plus other constituents in there as well. But as was mentioned, there's a lot of pretreatment that needs to be done because these membranes are subject to fouling and scaling. So these are just contaminants, as you can imagine, in seawater. We have algae. So algae can stick to the surface, and it can block the area for the water to diffuse through the membrane. Similarly, we have scalants. Our water's pretty hard in Arizona. You've probably seen, around your faucets, you have mineral scalant buildup. That can build up on the membranes. So there's a lot of things that we have to do in order to maintain our membranes. We have to clean them periodically to make sure that we're, maintaining this high permeation rate. So yeah, so to reduce energy essentially as well.
So everybody who has to help your kids build a science project for the science fair, you're all set, right? You know exactly what to do. So John and Chelsea, technology and technology's durability, both functionally and as new things come online. You must have to deal with that in your company all the time and anticipate.
Absolutely, and I think Arizona is in a wonderful position to develop leadership that could and easily, I can imagine can function at that global scale. There's a related adjacent technology, direct potable reuse, treating wastewater for eventually direct potable reuse, much as people do when they're orbiting the Earth on the space station. And so there's technologies that are being developed, and Arizona is a clear leader in the development of advanced water and advanced wastewater treatment. And Arizona is known and recognized on the global stage. There's quite a few people from Arizona that were recently at the International Desal and Reuse Association's meetings over in Spain last week. And so I think Arizona is already leading in many of these technologies that are adjacent. And clearly, as we start to look at brackish groundwater, you look at what Phoenix is doing in Buckeye and Goodyear. There's a lot of technology and expertise that's being built in Arizona, and so it's very easy for me to imagine that expanding as WIFA starts to look forward at what might be in our future.
Yeah. And Chelsea, when WIFA issues this RFI looking for possibilities, how much is the new uses of water that we might have in the state? Think about chip manufacturing. How much does that figure into what you want to hear from the respondents?
It's a great question, and it's really shaped the way that we're going about doing both the RFI from industry saying we can bring water into the state, but also how are we engaging the stakeholders that are the likely off-takers of that water? It's going to be expensive, and there's no way around that. Imported water is going to be much more expensive than what we are typically used to paying for water that is the water we use in our cities and that we use in agricultural contexts. But what we're doing as WIFA is actually going out to those potential stakeholders and asking them, how much water do you need? Where do you see WIFA playing a role in getting you that water that you need? And how much can you afford to pay for it? Because we can all day long go out and ask industry what we can do. We can build this beautiful solicitation that says these are the kinds of projects we want you to come in. But if we don't have a target to aim at, it's kind of pointless. We don't want to bring in too much water, although I'm not sure we could. But we don't want to bring in too much water at too high a cost. We don't want to bring in too little water and then sort of use that investment and it's not the right size for Arizona. But we're going to allow the actual needs of stakeholders as they're identified by the stakeholders to drive what the right size of that project is.
So you have hit on the essential Arizona question, supply and demand,
Yes.
which would suggest you sort of need to know that before you pick your solution, right? And so I assume that's well underway in some way, shape, or form, or is that expected to be part of the response to the RFI?
So it is a parallel process. The responses to the RFI will be much more industry and technology and financing driven in terms of the people on the back end of the project. Our process in parallel as WIFA staff, honestly, my process, kind of one of the reasons they brought me on board is to do that stakeholder outreach. So they're happening at the same time. The results will inform one another and they will both inform the eventual procurement solicitation process.
Right. And the procurement could include solutions like we're talking about today. You just mentioned reuse, John. I think our friends out in LA have a $3 billion, $4 billion plant they're using. So the creation of new water can come from the water that we already have, not just finding it somewhere else. So all that's on the table?
It's on the table. The statutory mandate for WIFA divvies it out 75%, 25%. So of the $1 billion that's been committed to our authority, 75% at least is what we are supposed to use for importation of water from outside the state's borders. But there's 25% or up to 25% that we can use for those in-state solutions, be that direct potable reuse, if it's helping folks invest in the 91st Avenue wastewater treatment plant. It could also be for just increased water infrastructure in the state, expansion of the Bartlett Dam and helping municipalities buy into that, or yet to be determined solutions as well. That's, I think, a little bit, it's the lower hanging fruit because one, we can only make loans to do that. We know how to do that. We know how to do low cost financing. But two, I think those solutions, the universe is a lot smaller for those solutions, or at least a lot more identified for those solutions versus the out of state, which is a whole lot bigger, which is why we needed the RFI.
And Kerri and I were chatting about this before. When you say 75% of the solution probably comes outside the borders of Arizona, 25% in, it suggests that maybe you've done some back of the envelope kind of calculations that you know probably how it's going to be worked out. Is that unfair to suggest that?
Probably so, because that 75-25 came from the legislature, and as much as I love our friends down at the legislature, those
Enough
kinds
said.
of numbers
We're all
tend to
good.
be less artful than that. And I would also probably hesitate to classify it as 75% of the solution versus 25% of the solution. It's 75% of the funds versus 25% of the funds. That may not correlate to 25% of the acre feet of water. It's just that's how our statutory mandate to spend the water is divvied out.
So Chelsea brought it up, but she didn't name the number. You're a numbers guy, Glenn. So what do you figure the cost of this water is, in your estimation, coming from a desal plant like this versus the cap expense, which is in the neighborhood, people in here would know better than I would, $300? Maybe an acre foot, something like that, plus or minus? What do you think
I
this
think
is?
you're going to go above that.
Yeah, I think so.
I think it's going to be, it's no different, and I tell the story all the time of, 5 years ago, we paid $10 for cable news or cable coming into your house. You pay $300 now. Why is there no pushback on that?
Well, you got to push that news uphill, and those hills are.
So water is a more controversial discussion. It comes up more and more. I get the really interesting position, unlike some of my colleagues here. I get the first phone call from the chairman of White Claw that phones me up and says, I'm going to put a 1 million square foot plant in Arizona. You got water? I get a phone call from the senior VPs at Nestle. You got enough water? I get the phone calls from mining companies going, so dude, do we have water? I get phone calls from agriculture buyers going, will Harquahala exist in the future? And so one of the things that we have not done a good job of is explaining to the world our long-term plan. Other places around the world are doing this. Cycles move up and down. And if Arizona, I'm not saying it's the right thing to do, but if Arizona continues on this growth plan, and the same thing for Sonora, they're one and the same. If this occurs, as the global re-entry into this market occurs, what we pick, I really don't care. Where it comes from, I really don't care. What it's priced, the market will tell you what it's going to be priced. But you better have something in a story that says we have a long-term plan and we're moving towards it. We're not discussing it in academia. We're not discussing it in the legislatures. We're not discussing it in boardrooms where finance is. We're ready to rock and roll. We have studied water infinitum. There is no other subject in Arizona that has been better studied. Now, the difficulty is pull the trigger.
But you made some assumptions there.
Yep.
Well, we're growing like crazy. We're going to keep growing.
I'm saying yeah.
Maybe not, right? That could be
not.
one of the answers. So can we handle the truth? Because the implications for water that you said is way more expensive than $300, which could be 10 times more expensive. Okay, we're getting ahead. What does that do for the landscape, literally and figuratively, of Arizona? What changes? What changes about agriculture, business, our own homes, watering our yards? John's nodding his head. He wants to answer this question. What does that world look like when water is at that number, and how much of that water are we dependent upon?
So typically, the cost of water in Arizona, you can drill a well, and you can put in a tank, and you can pump it. It's about $400 an acre foot. And we've taken, great advantage and leverage of that water. Obviously CAP was more expensive. But as we go forward and start to look at, Texas has estimated brackish groundwater desalination is about $1,000 an acre foot. So that's, and then as you get into desal, you're going to be up to $2,000, $3,000 an acre foot as it's financed out over time. But the clarity that brings is all of a sudden we start taking much better care of our water resources. And, I live in Tucson. There's a golf course about 10 minutes from my house. It's not a golf course anymore. That water And that, just in their socioeconomic background, Tucson basically, obviously decided too many golf courses. And so they're starting to think, what's the highest and best use of that resource? And so I think what we'll start to see is we'll be doing different things with the water that we have. And that change behavior may push some of these solutions, you know, down the timeline quite a bit, which I think is a wonderful thing. And so as we face a higher cost for a resource, you're either going to decide, well, maybe I don't need it, or there's a better way to do it, or it'll foster innovation. So I think it's going to be a very dynamic series of evolutionary steps that we go through in Arizona as we step through that. You know, there's inexpensive water. Good luck finding it these days. What are we going to do next?
Okay.
And how far do we go?
We do want to draw some questions from the audience, and while you're formulating those in your head, I just want to get Chelsea's response to this. Are you expecting in your RFIs people saying, here's our suggestion, it's going to be a changed world? Are you expecting them to detail that for you?
I think so. I think we're expecting to see what is that new behavior going to look like. And I think we're in a very good position as WIFA because we're not here to dictate what that new behavior looks like. That's not our job. We are not a regulatory agency. We are not the Arizona legislature. We're not the Department of Water Resources. Instead, we're going to take what do our potential customers believe that outlook to be, and how do we fit into that outlook? And I say that because one, I'm really glad I'm not that regulatory agency and that I don't have to be making those difficult decisions. But I think Arizona has a long history of making those decisions very well and very collaboratively, and I expect that to continue into the future.
How about I give you the last word a little bit later? Can you
Do whatever you want me to do.
Can we handle that?
Good.
I want to make sure if people are really chomping at the bit here, because I know we've only got a few minutes to ask a question.
Yeah, we have about 10, 15 minutes for questions.
Okay. Oh, I see one there. Okay, let's do that. I'll get back to you.
And so I think for responses, let's have it from no more than 2 panelists.
Yeah, we'll start that. Yeah, if you can direct your question to one of the panelists, that would be really helpful based on what you know about them.
Sure. So my name is Marlene. I just have a general question. I know you said that in the future you guys would have some discussion about the Mexican government, but overall, can you touch at least how receptive they have been to this project?
You're there quite a bit.
I'm there all the time. We have done a terrible job with the Sonoran government of assuming that we're just going to take their water. And it's a very poor political position that we took. We're changing that.
And sometimes the we isn't necessarily us or people coming in and suggesting things. The suggestion could come from anywhere, but not very well formulated.
So it's something that we're looking at totally different now collectively, that we want to have, if this goes down that road, this is really up to the governor of Sonora and the Sonoran people, do they want to play? And once that's established, then you can take a look at what comes next, if this goes down that road.
Yeah.
And I would just add to that too, that there are processes and systems set up in our treaty with Mexico that anticipate desalination. This is not kind of a new idea. This is something we have contemplated. We have a state designated negotiator with Mexico. I think it's very important that those processes happen through that process, right? And that we make sure that it is our negotiator doing the right things, that we don't kind of have people in the mix that don't need to be, that are messing that up. And one of the things that's going to be critical is that we don't present anybody, regardless of where this project or program will be located, with kind of a fully baked idea, but instead it is, how do we solve the problems that you have, and then how do we do the same thing for us and make this work for any community that a project touches.
Great. We have 2 questions back here and then over.
Hello. Sort of a general question for whoever has expertise on kind of the lifeline, like the longer term implementation of a project like this. You're thinking about, not only the philosophy, but the regulatory framework, in Arizona of growth paying for its associated growth. To what extent can a desalination project, of this scale, kind of scale supply with growth, with the associated demand that comes with new growth? In a sense, how do you prevent putting the current generation on the hook for the costs associated with a project of this scale, who might not even see the water from it, or how do you prevent a community financing a project like this before they necessarily have the rate base to finance it?
Private sector steps up. So the private sector pays for it up front, and government comes in behind. It's a reverse P3. And that way, institutions that do this for a living around the globe, that build the Suez Canal, or build the subway in Paris, or build the ports in Dubai, say they take a look at Arizona and they go, you know, you guys might have something there, and if you continue to go down that path, there are financing mechanisms globally. So you have to take yourself out of the regional context and look globally. Because Arizona, with what's going on with semiconductors now, has really changed its perception globally, instantly. And there are very, very big players looking at this market going, this could be an opportunity. What do you have? And if we walk in there with a $200 million deal, they go, see you later, or $100 million, or $2 billion. They start at $5–10 billion. And that's if Arizona chooses to go down this direction. That is a good thing to have. Now, where it gets fascinating is the people in Arizona that are selling these types of things are selling them 10 years out. So the question is, what are they promising? And how is that going to be fulfilled? And is it going to be driven by economic development or professionals like this being heavily involved in the water community saying, you know, maybe we should get together and help design what that long-term thing is and give it to the salesmen, the economic development community of Arizona, as a tool that they then work with that was designed by professional people and understand the economics of the whole thing.
I'm really proud of how the water industry has recognized that the infrastructure it designs has a serious impact on the community. And you raise, you know, issues of equity and generational equity and true sustainability and understanding affordability. Your question gets at the heart of affordability and equity. And it's been amazing to me to watch the water industry that used to talk a lot about pipes and pumps and valves really understand the human side of, and the transportation has as well, you know, interstates, you know, cutting communities in half. It's been really wonderful over the course of my career to see the engineering profession start to recognize that if you don't address those, you have a failed project.
This is great. I'm just going to ask the panelists to keep it a little bit shorter so we can get in a few more questions.
All right.
Hi, everyone. Thank you for the talk. I know it was mentioned briefly, but I want to know if we could dig deeper on why it's the biggest part of the budget dedicated to importing water. Even if we could apply all these water reuse stuff and other practices as in Tucson, it wouldn't be enough. We will still have Arizona will still have to import water.
So I think that policy decision was driven by a couple of things. The main being that the resources for importing water out of state weren't really there or aren't there the same way that the resources are there for some of these in-state projects. When you look at direct potable reuse, you have cities that are already coming together. You have Phoenix kind of leading the way saying, we want to do this. We think we can bring the financing together. They didn't necessarily need state financing to do that. The Bartlett Dam is another very good example of that. SRP doesn't really need WIFA's money to do something like that, or the state of Arizona's money to do something like that. But to attract serious augmentation proposals and to attract this new innovation and these new ideas of bringing water in from out of the state, we really needed something flashy and we needed something big and we needed something serious. And so that's why I think that most of the investment was really geared at bringing water from outside of the state, while still recognizing the importance of incentivizing and helping some of those in-state reuse projects.
I think in some of the answers here, I could imagine a whole session around this question where we talk about the pros and cons of public and private sector involvement, since those proportions are going to change, and the implications of that, have we seen it in other utilities or other things. That's worth an interrogation at some point when we pick our solution and how it gets financed, I think.
Yes, my name is Enrique Vivoni. I'm a professor here at ASU. There was a comment about the need for a story. We need a story to sell for the $19 billion that is coming from the private sector. as opposed to the 1 billion coming from the government sector. And there's a story, but it hasn't been communicated well, about Sonora and Arizona called La Mega Región, the mega region. It's one desert, it's one climate, it could be thought as one economic entity. And if it's one economic entity, you're not importing water. You're simply sharing it within the mega región. So the question, so that's the background. The question is, for that to be true, we have to interconnect many of our systems. So interconnecting the water is really just an opportunity to interconnect the broken transportation system, the grid system that isn't connected, and so forth and so on. So I'd like the panelists to comment on this as an opportunity for integration where water is simply the first stage.
So I'm going to ask maybe Kerri to take this. You live in Tucson, but you're closer to Nogales than we are today. Maybe you could take it first and then share the question.
I think that's a great question. I think even, yeah, we need to zoom out and realize what the community needs are. And part of, why we just can't keep all of our water here, why we need to import water, is because we export a lot of water. Agriculture is such a huge part of the economy, of the culture here. There's mining, copper is another big resource, climate, golf courses, like these are all really big economic drivers. They aside from these high-tech manufacturing jobs, they are really kind of the bread and the butter of what we do and a lot of the culture that we have in Arizona that we're so proud of. And so, it's a challenging one because it's such, it is the technical stuff, it's the environmental and the cultural stuff, and then and the prosperity. So yeah, I think we really need to think more about that and talk to other states too, and have better agreements with how we use water and what, how we're transporting it. And yeah, I think that's a really good point. Yeah. How's this all integrated?
Where in the back? Oh, one more question. Yeah, yes, sir.
There he is. My name's Rachel, and I just have a comment/question. And it's to the point of the cost of the water and the processes for the desalination. So, is it John?
Yes.
Okay, thank you. You made the comment that a change in behaviors based on higher costs may foster innovation. If that is the case, because I think back several years to California with the water shortages and how, there were allocations and such, but it only lasted for a certain period of time. It didn't change, the water necessity didn't change, but over time it seems like people were comfortable and they stopped applying those same behaviors. So is it possible to take that into consideration to include more long-term measures to ensure that the water, if it is imported, can last? Because that seems to be the issue that was even mentioned here by, I think it's Glenn, the long-term goals and how we reach those, because in our city, in Maricopa, we have water short-term, medium-term, but for the long-term, that's the issue. So if we are bringing more business, more commerce, what can we do, and how can we ensure that these measures and these behaviors are changed, because it is an expensive commodity?
So at the heart of it, we're talking about a human challenge, and to design infrastructure and put pipes in the ground and build large treatment plants. At the end of the day, if you're not bringing in that human factor, bringing it in up front, questioning, and also developing scenarios and not assuming that you know what people are going to do. And the broader you look in your scenario planning, you start to reduce the risk of something surprising you. And then humans will surprise you anyway. But it's really part of the art and science of engineering and thinking, and the science that we need to put in place is start with the human, start with the people, and what do they need, what can they do, how can you empower them, and then recognize they're incredibly creative, and they may adopt new practices. They may, get bored with something, and try and build that in through scenario planning. And I've been excited again in Arizona to see some of the scenario planning. Tucson Water's new Tucson Water 2100 plan is built around, we have 4 possible futures. Where are we going to end up? It's up to all of us to decide what sort of a community, each part of Arizona and the mega region becomes. So if you ignore that at your peril when you're pulling out your calculator.
So Paul would like me to wrap this up pretty quick, but he also invited me earlier on to advertise this a little bit 10 across, and I wasn't going to do that except because of Enrique's question. It would seem that the artificial policy boundaries and jurisdictional boundaries we put up between cities, between states, between countries, are potentially overcome. 10 Across Project, we think a lot about El Paso and Ciudad Juarez. Why isn't that thought of the way you're talking about a singular urban district? But it's not, for obvious reason. So if we as a nation and a society can overcome some of those artificial boundaries, I think we have a chance of solving some of these water problems in the process. So I want to thank our panelists today for your insights and your time, and thank the audience for coming. Thank you very much.
And finally, we also want to thank Duke for moderating this session, so thank you very much.
Happy to do it.
And also for Dave and Savannah and others that really helped organize and facilitate something that was great. We could stay here many, many hours, but as Enrique said, there's a game on. There's a game on. Thank you. Enjoy the cookies.
Thank you.
Go do that.
You're welcome.